Hello everyone, welcome to the 9th part of the video tutorial series Learning Pandas from Zero. My name is Sheng-Chi Leung, and in this tutorial I will be your guide in Pandas. Today we will start talking about the application of Pandas. We will focus on two interesting methods, the group by method and the aggregation method. They are very often used in getting efficient partition of a large data frame and their individual statistical features. Let's recapitulate what we have learned in our last tutorial. We have covered how to set up index and combine multiple data frames into one. We have learned how to use the index as a means for classification. We have shown that by using multiple indices, we can achieve some tree structure to classify entries by its column features. We have also learned the merge method to combine multiple data frames by matching common columns. Now we will do something more. In the chapter, we will introduce two important applications. First, we will learn how to partition a data frame into a number of smaller data frames by using some unique features along one or more columns in the original data frame as the criteria. Then we will learn how to find out efficiently some collective features, such as statistical quantities in all the partitioned data frame. Let's take a look at the example of the fiducial data frame on the top right-hand corner. It contains the name, gender, and age of some staff in the company. One way we may partition the data frame can be by the gender, just like the entries surrounded by the red and purple boxes. We can ask Pandas to segment the data frame into two according to the gender. And then we can find some aggregated quantities in each box, for example, the average age. So let's take a look at the syntax. Pandas has the method group by, which we need to pass the column header as an argument. The effect is similar to the method setIndex we have discussed in chapter 8. This means we can pass more than one columns, and Pandas will further partition the data frame into smaller ones based on the number of columns you provided. For more than one columns, we use a list or a tuple to store all the column names or headers. Let's take a look at the example. Here we have a large data frame, which is similar to the data frame we discussed in chapter 7. It contains the name, ID, location, and so on of the staff in the company. There are many ways to group the data. Let's start from the simplest one, by making two subclasses according to the gender. We write on the left-hand side the variable we want to store the data frame and right-hand side the original data frame. And we pass gender as we want to use the column gender as the classification method. Notice that the group by method does not give you directly a data frame, but a grouped by object. In a group by object, we can check the groups and indices. We notice that it contains the label F and M, which are unique features along the column gender. And for each column, a list of number, which are the row index in the original data frame. From this, we can see that the group by object is like a phone book, which contains the link to the original data frame according to the feature we want to use. Many of the methods and attributes of a data frame can be applied to a group by object because of its data frame origin. For example, we can use the link to find the number of labels in the object. The head and tail will reveal the first n or last n entries in each data frame. Size has a similar function as the one for data frame. Notice that, different from a single data frame, this method will give us the derived quantity from all partitioned data frames. For example, if we use size to the df grouped object, we have both f and m being 4. This means there are 4 entries for both subsets data frame with the gender being f or m. There is a new method specific for the group by object is the nth method, which lets you output the first nth line from each of the data frame. It has a similar function as the method head. The virtue of the group by object is to provide automated way to access all subsets at the same time. But this also means we do not want to access individual data frame subset for the operation when we use the group by object. A group by object is a general dictionary which contains the keys and the values. The keys are the label we have mentioned, the unique element from the original data frame. The values are the index of the relevant entries from the original data frame. To look through the iterable, we need two variables to store the data. Here I use index and group as examples, but feel free to take any variable names. An example shown here, in the first loop, Pandas returned the subset for the female staffs in the original data frame, and the corresponding entries as well. In the second loop, the part for male staff is returned. Once we have partitioned the data frame, the next thing we can do is to find out individual statistical features in each of the subgroup. The way to call the method is easy. The method aggregation, or simply aggregate, can be directly called, and in the argument we pass the function name we want to use for the calculation of the derived feature. For example, when we type dfgroups.agg and in the bracket sum, Pandas returns us a series object where we can see Pandas calculate the sum of salary received by all staff in each group. When we have multiple methods to pass, we can use a list or a tuple to store the methods. You may wonder, there are many columns in the original data frame. Why is there only salary in the output data frame? The answer is that Pandas will automatically identify if the method can be applied on the data. And naturally, the method sum can only apply on numerical data. Here we show an alternative to access the group by object. We can specify a particular column using the index notation and then apply the aggregation. Any function which is common in Python, such as the sum, max, min, and so on, can be used readily. We can also import functions from other libraries, such as the NumPy library if the original Python library does not contain the method. We can further define our own method as well. The process is similar to the method apply we have discussed in chapter 6 and 7. Notice that the aggregation can also be used to a general data frame for any column or row. For example, we can use it if you want to find the sum of any columns or rows in the data frame. Finally, let's exercise and see if you have mastered the technique we have covered today. Your friend comes to you again and shows you this new data frame. It seems that your friend is working in a survey bureau instead of a fruit company. We can see from the data frame that it contains the name of the place, whether it is a city or a village, and the number of inhabitants in that place from 2000 to 2004. Now your friend needs to achieve the following tasks. Can you help your friend? Again, feel free to pause the video so that you have extra time to try it on your own. Let's take a look at the solution. The first thing we need to do is to group the data. This should be now very trivial for you. We only need to use the group by method and pass the column name, namely type. Then the output variable dfgroup will be a group by object by default. You can also check its member by checking its group attributes. I show the results on the right-hand side. For the second question, we need to find the average of relative population growth in city and in villages by comparing the population in year 2000 and 2004. To do so, we need to return to the original data frame and build a new column called change. This column calculates the relative change in each place. Notice that we cannot directly add new column in a group by object. Then we grouped the data frame similar to the first question, and then we calculate the aggregation. I remind that there is no average function in Python, so I import it from NumPy and pass it as an argument. And then we have the answer. City has a positive change while village has a negative change. It means that the city population is growing while there are fewer people living in the villages. So that's the end of our live tutorial video. And once again, thank you for watching this video. I hope to see you again in the next tutorial. We will learn how to use Pandas to build a pivot table. Again, practice makes perfect. I will encourage you to also read my open source ebook to do some of the related exercise to strengthen your skills. I hope you have enjoyed the tutorial today. See you.